Alright, we looked at the definition of certain terms like nodes, loop, branches, meshes, a bunch of different terms. Let's look at a simple example that demonstrates in a very easy sense the definitions that we just saw. Okay, so here is the circuit given, and then we are supposed to find all the nodes. Okay, what are all the nodes that are present in this circuit, and what are the essential nodes, the branches, essential branches, the meshes. These are all the um, circuit um, terms that we have to identify in the circuit given here. Okay, and then there are some questions. Find two paths that are not loops or essential branches, and of course find two loops that are not meshes. Okay, so let's start with the first one, node. Think about this. Let's go back to the definition of a node. Okay, a point where two or more circuit elements join. Okay, a point where two or more circuit elements join is called a node. Remember? So we are going to look for points that where two or more circuit elements join. Okay, so clearly we can start here. A is a node because two circuit elements, the voltage source V1 and the resistor R1, meet there. So is B. You see, B is a node as well because there is a resistance R1, there is a resistance R5, and you see there is a resistor R7 connected to the same node. Okay, and there is a current source I connected there as well. So B certainly is a node. Okay, then C, look at C. On C there are at least three circuit elements: voltage source V1, voltage source V2, and resistance R2. These are connected, these are meeting at that point. That meets the definition of a node. Same for D as well. If you think about it, at this point D, two circuit elements R2 and R3 are meeting, hence it's a node. Okay, the same goes for E as well. For E, there is at least 1, 2, 3, R5, R3, and R6, three circuit elements meeting. Okay, so the same with F. F is a point where two circuit elements V2 and R4 are meeting. The same with G as well. Okay, the same with G as well, where there is more than one. You see, this R7 is meeting here, R6 is meeting, R4 is meeting, and I1. So there is actually four circuit elements meeting there. Okay, so G is also a node. Now, to clarify, let us see, is this guy a node? And is this guy a node? Okay, it's, you can call it a node, it's the same node as G. Okay, so this node and this node at G are not different, it's the same node as G. Okay, they're not different nodes. So what are all the nodes? The nodes are A, B, C, D, E, F, G. These are the nodes. Now we are supposed to find the essential nodes. Okay, let us see. I'm going to copy this. Okay, let's see if I can copy that and paste it over here. We are trying to find the essential nodes in here. All the nodes are shown in red, and I want to show the essential nodes. Now, what is an essential node? Let's go back to the definition here. An essential node is where three or more circuit elements join. Okay, let's go fish for those. More than one circuit elements. Let's start with B. So B is certainly an essential node, right? I'm going to show it with a star. Okay, B is an essential node because R1 is meeting, R5 is meeting, I1 is meeting at the same node, and R7 are meeting at the same node. So both of these nodes, this node and B, I'm calling them as the same node, right? So B is an essential node because more than one elements are joining. A is not an essential node. A is not an essential node, right? Because there's only two elements joining there. How about C? C certainly is an essential node because there are more than two, there are three or more elements joining there. Now D is not an essential node. E is an essential node. F is not an essential node. G is an essential node, right? Because there is 1, there is 2, there is 3 and 4. 4 circuit elements meeting at G. Hence, it is indeed an essential node. So the essential nodes are really B, all the ones that I have shown with a star, C, E and G. These are the essential nodes. Simply more than one circuit elements are meeting there. Now, the next part of the question is find all the branches. Okay, what are the different branches in this circuit? So before we solve that, let's go back to the definition of a branch. A branch is nothing but a path, right? It's nothing but a path between two nodes. Between any two nodes, you can have a path. That path is called a branch. Okay, so let's see. Let's start with this path A. Okay, or maybe it is easier if I copy this. Okay, I'm going to copy this circuit again here and start on a fresh page. Copy this. So we looked at essential nodes so far. Here we are going to talk about branches. Okay, we are going to look at not branches. See all the branches. That is what we are interested in finding. Okay, where are all the branches? Let's start with A. Okay, so between any two nodes, think about it. We have a what color shall I use? I'm going to use okay. I'm going to pick. I'm having a crisis of choice here. Now the branch, this guy, okay, between two nodes, the node A and node C, in between them, that's a branch. Okay, so is V2, the branch between the path between C and F. Okay, so that's a branch as well. Now think about it. There are two nodes A and B. Now the path between these two nodes, that is a branch. So let's start by listing them lest we should forget. So V1, which is a path between node A and node C, is one branch. Then V2 is another branch, right? Then we just identified that R1 is a different branch. So is R2, right? So let's see, R2 is between the node C and D. Okay, and so is R3. R3 is a path between node D and node E. Okay, so R2, let's list them as we go. R3, so is R4. Okay, think about it. R4 is a path between two nodes, F and G. Hence, that is a branch as well. Okay, so that's R4. So a bunch of different branches. R5, is R5 a branch? It is indeed a branch because it is in between two nodes, node B and node E. Okay, hence R5. Let's see, we got R5. What else? Did we cover the node E and G? Let's do that. In between node E and G, I have a branch. Okay, and that branch is R6. The resistance R6 is sitting in the branch. How about this guy? The R7, the branch R7 is actually between the same nodes B and G. That's a path. Okay, so we got R7. The only thing remaining is this guy. Between the nodes B and G, there is another path through current I. Okay, let me see if I can move these just a touch so I can put them all. So these are all the branches. We set out to find out all the branches. All the branches are listed here. Okay. Now, which of these are essential branches? That's the next part of the question, right? So, essential branches, that is what we are interested in finding. Okay. What are the essential branches? Now, what is the definition of essential branch? A path between two essential nodes. Okay, the path between two essential nodes is what we call a. So let's copy this circuit. Okay, let's copy this circuit where we identified all the essential branches, essential nodes. I meant to say. So here is the circuit, and when you see a star next to the node, you know that it is an essential node. So in this part, we are interested in calculating or in listing all essential branches. Okay, an essential branch, again, if you remember, it is a path between two essential nodes without passing through another essential node. Okay, so the essential branches are from V1. So let's start here. There is my essential node, and here is an essential node. So basically a path that I can take from here to there, from C to D, that is an essential branch. Okay, a branch between two essential nodes that does not pass through another essential node. Okay, so C through A through B. Okay, that is an essential branch. Similarly, the other essential branch is, by the same logic, I have C and I have E. These are two essential nodes. So basically a path, okay, or a branch between these two, okay, a branch between these two nodes. So R2, R3, that certainly is an essential branch. Okay, so let's list so far. What do we have so far? Let's we have V1 to R1 is one essential branch. Okay, then we have R2, R3. That's another essential branch. The branch through R2, R3. Okay, everybody with me? Now, what else? V2 to R4. Okay, so let's continue this analysis. Now we started at node C, and from node C we are looking at the next essential node. Okay, so one essential node is C, and the next essential node is G, and the path between that, okay, the path between that certainly is an essential branch. Okay, so V2 R4 is the third essential branch. So V2 R4 is the third essential branch. What else? R5. Look at this. B is an essential node, and so is E. So simply R5 is one essential branch. That's easy enough. Okay. Then the same logic between G, okay, between G, okay, and E. Both of these are essential nodes. So the path between these two, this guy is an essential branch R6. Okay. Similarly, by the same logic, R7 is an essential branch because it is between B and G. Okay, and so is I. Okay, both of these are between the essential node here, B, and between B and G, right? So I have this path that is an essential branch, and so is this guy. Okay, so is the current source I, which is essentially between this essential node and G, the essential node. That guy is a path, an essential branch. So we have listed all the essential branches. Cool. So everybody understand the idea of an essential branch? It's simply a path between two essential nodes. That's all. Now, what's the next one that we are supposed to find? We are supposed to find all the meshes, right? In order to find all the meshes, let's copy this again. Okay, I'm going to copy this circuit and then paste it all the way over here. There you go. And in this part, we are looking at all the meshes. Let's see, let's find all the meshes, which is E. In order to understand, in order to be able to find out all the meshes, let us see what the definition of a mesh is in the first place. Okay, a mesh is a loop that does not have other loops. Okay, mesh is a loop that does not have other loops. What is a loop? A loop is a path that begins and ends at the same node. Okay, so if you think about it, there can be any number of loops. You start here, okay, you take a path, okay, okay, then you end up on the same node that you started. That's a loop. Okay, you begin and end on the same node. That's a loop. The same here as well. You can, I don't care, you can start here. Okay, start on this node, then take a path to the left, down below, to the right, go to the top, okay, and then come back and then end at the same node D. That's a loop as well. If you begin and end at the same node, then it is called a loop. Okay, if you begin and end at the same node, it's called a loop. Now, we are interested in finding the meshes. A mesh is simply a loop that does not have other loops. Okay, so let's find out the meshes in here. Now, let's start with, as we have been doing, let's start with this circuit element. In the past, that's what we have been doing. So let's start with this guy. We'll start here, okay, and then take a path to R1, okay. Then we go down to R5 and go through R3 and R2 and end up on the same node C. Okay, so now we have completed a loop, and this loop does not have other loops in it. Therefore, that's a mesh. Okay, so let me show that. I'm going to show that to you using this loop. Okay, therefore, let me list that here. The first loop that I have identified is through V1 to R1 through R5 through R3 through R2, okay, and back to node C. Okay, that's one loop, uh, which is also a mesh, right? It's a mesh. Now, let's look at the other mesh. Let's start by following a different path now. Let's start with V2. Okay, let's start with V2 and go down to R2, followed by R3, followed by R6, R4, and end up on the same node. So this path, including these, that's a mesh as well, because it's a loop that does not have other loops. So the second mesh that I'm going to identify is through V2, okay, followed by R2, followed by R3, then R6 and R4. Okay, so let's make it really quickly. I'm going to show it using this color. Okay, everybody with me so far? So that's the idea of the second mesh. Now there is one more, couple more meshes actually. If you think about it, R5, starting with this node R5, then go down to R7, which is here, and then end up in the same node E. Okay, so this path, that certainly is a mesh. Okay, so this guy, see, that's one mesh as well. So the third mesh that I'm going to write here is really R5 through R7 through R6. Okay, and there is one more. Okay, there is just one more mesh. The other mesh is, if I can use the color, what color shall I use? I shall use the color red here. Okay, now you start at any node and then end on the same node without having another loop in it. A loop that does not have other loops. So in that sense, by that definition, so we have R7 through Ri. That is another mesh as well. Everybody understand the idea of a mesh? We are going to apply what is known as a mesh current method. Okay, so it is very important that we understand a mesh. For a fun exercise, I'm going to ask you to think about this. Start here, okay? go through this and end on the same node F. That is a loop, right? You begin at the same node, end at the same node, but it is not a mesh. Why is it not a mesh? Okay, go back to the definition of mesh and understand why it is not called a mesh. Okay, it's only a loop but not a mesh. Okay, now so let's quickly progress here. We looked at A, B, C, D, E so far in the problem. The problem asks us to find nodes, essential nodes, branches, essential branches, and meshes. Now we are interested in finding two paths that are not loops or essential branches. Okay, let's remind ourselves. We are interested in finding two paths. It's a connection between two elements, two adjoining elements. Now, it should not be an essential. The problem asks us to find a branch or a path. Okay, it asks us to find a path that is not a loop or not an essential branch. Okay, so an essential branch is a path between two essential nodes, and a loop is a closed path. Okay, so let's copy this then, and then identify some copy this and identify the two paths that are not loops. Okay, let us find two paths that are not loops, and then that are not essential branches. So as long as we avoid the essential branches, we should be okay, right? And then if you remember, we did identify the essential branches earlier. What were the essential branches? Go back to the last problem. Go back to that problem. You remember that B was identified an essential branch. We starred C, we starred E, and we starred G. Okay, so we know what the essential branches are. Okay, now if you look at the path R1, R5, and R6, okay, it is a path R1 through R5 through R6. So that's this guy, R1 through R5 through R6. So this is certainly a path, but it is not a loop because it is not ending back on the same node. If it were ending back on the same node, it's a closed path, then it would have been a loop. But it begins somewhere and it ends somewhere. Okay, it's not an essential branch because it does not connect two essential nodes. One node is A and the other node is G. So this path R1, R5, R6 is, so let me identify one, R1 to R5 to R6. That certainly is a path, but it is not a loop, nor is it an essential, okay, nor is it an essential branch. Okay, so that's one we identify. Let us see V2 through R2. Okay, very easy to note is that if you start at node F, go through V through and end at node D. Okay, to be specific, I am referring to this path starting at F, going through C, and then going to node D. So the second path that I am interested in, okay, the second one is really V2 to R2. That is certainly a path. It is not a closed path, and it does not connect to essential nodes. Hence, we are looking at two paths. Okay. Now, the last part of the problem, G, where you're supposed to find two loops, okay, which are not meshes. So identify closed paths, that are not meshes. That part, I leave it as an exercise to you. But what we have done in this section 4.1 essentially is to define a bunch of terms and then look at the application of these terms in an example problem. Okay, so we are going to stop here, and then when we come back, we are going to look at section 4.2. But it is very important that you understand all these definitions, because you will use them again and again in the next sections, next chapters throughout the course. See you.